Good day from Winnipeg, Manitoba, Canada. This is Todd Levenenko, and I'm going to be talking a bit about a little project I've been working on over the last couple of weeks. And it's called Weather Stats. Basically, what I want to do is I want to determine whether or not the temperature outside in Winnipeg, Manitoba is going to drop to minus 30, and if so, what the probability is for that to happen. I'm using two programs. One is Python, and this is PyCharm I'm using. It's one of my favorite Python tool sets. Here you have the project, what projects you're working on. You get to see some output events, and you get to look at your application, the data you pulled, and the results of your data. So what I did was I went on to a website that contains data for Winnipeg, and I wrote a little Python script to pull that data, and I brought it into a format called weatherstats.csv. Here, the weatherstats.csv, we have a day num. I've determined whether or not already did a bit of massaging. If it's close to, if it's colder than minus 29, I'm going to consider that a pass. The year that it happened, right here, and the date, as well as the minimum maximum temperature. What you'll see though is that I want to do some cleaning up here, because year I want to pull out, and I don't want the month or day for this particular project. So this is it. Lots of data. As you can see, I pulled out 29,516 records over the period of time. So I got a good sample size. What I'm going to do now is I'm going to show you a little program that I wrote. I import a CSV, which is basically an application that is going to do a lot of my work with respect to reading the delimited file, and I'll be able to output that file into the weather.csv file. So as you can see, I created a file. I'm opening up the weatherstats.csv file as a read mode. The reader is going to read the file in a delimiter of the comma that you saw here in the comma separated file. And I'm going to generate a results file where I'm going to output the weather out.csv, which is right here. I'll show you the output later. What I'm going to do is, because I don't know how many rows I have, the reader is going to read the file a row at a time until I exhaust all options. So it's a simple for statement. You'll see it in Python whenever you have a function like this, it requires a colon. The next step that I've done is I have to make sure that the first row, which is row 0 in Python, contains the header information, and I won't be able to do any writing of the header information, or that is cleansing of it, because they're not numbers, right? So what I did is I created a writer WR, and I'm going to read the CSV file, which I did through the row in the reader. And then what I'm going to do with the WR file is it's a write, and I'm writing the results of the row. So because the row is 0 and it's the first column is day num, that is the row of the first column, which is 0, I'm going to write out the header information. And that's what this is. WR writer row on the 10th line of this code writes out the row, and that row contains the header information. After that, I just do an else statement, and here I'm going to split row 2. Row 1, if you recall, if I look at here, row 0 is the day num. Row 1 is whether or not I pass or fail. Row 2 is the year, month, and day. Row 4 is also year, month, and day in this particular output. And the final row is the temperature, the minimum or maximum for that particular day. What I need to do is I need to split out that information. Now, Python doesn't have a left or right function that is similar to Excel. So you end up having to look for something, and in this case the split here is the hyphen. As you can see in the weather stats, there's the hyphen, right? So what I'm doing here is I'm splitting out the year, month, and day in row 2, because remember, row 1, the first row is actually row 0 in Python. So this is the third row, row 2, and I'm splitting it with the hyphen. What I want row 2 to contain is just the year. Now, because this is a CSV file and it operates in such a way, as you can see on the bottom here, everything is in quotes. It's not a number, but it's a string. Therefore, I have to take row 2, which is the third column, row, third column, which is 2, equals the string of the year. For the purpose of this demonstration, I'm printing out row 2, a row 0, and then the row that you could see in here. So as you can see, I print out row 2 is 1993 here, row 0 is 152, and then I print out the whole entire row, which is a list containing the day number, whether it passes or fails, the year, month, and day, and the temperature. Why is it 152? Well, what I've done also is that in my, what you'll see later on, is that I want to set the date for the purpose of graphing December and January, because January is the first and December is the last month, and January is the first month. I end up having a situation where my curve is going to be on the left and right hand side, and everything else is going to be flat and all zeros. So my ones are going to be on the left, my passes, which is 1, going to be on the left and the right of the graph. So what I've done is I've set the date to 181 days, which is July 1st. So July 1st is actually becomes the 0 day. The middle of the graph is where temperature goes to -30. So to do that, I basically do this f int. Now I have to take the row, which is 0. As you notice, it is a string, so I have to convert it to an integer. And I'm saying if it's less than 181, the value is going to equal to the int row 0, and then I'm going to add the value plus equals 181. So if it's less than 181 days, I'm going to add 181 days, and then I'm going to take the row 0 and I'm going to make it into a string value like this. Now you might say, can I not just put all of this into here and make it work? No, Python doesn't like that. It doesn't like mixing integers with strings and stuff like that there. So you end up having to make it into an integer, add the value, and then put the value back into the row. So that's what I did there. Now I have an else statement, because after all, if it's greater than 180 days, I want to subtract 181 from it, because I want to make July 1st 0. I have here the value integer again. I'm subtracting 181 days from that value, so if it's 200, I subtract 181, and I make that into a string value, and I put that into row 0. Similar function as above, through this for loop and through this else statement, I am writing the row to the results file. Then once I've done that, I close the file and I close the results. What does that give me? It gives me an output, and I'll show it to you. It's weather out. So unlike the weather stats, you will see that it's now been changed. If I look at weather stats, I have a 0 for day num for 2018-01-01. It's a pass. I've now changed it to 181. So 181 days from July 1st is now January 1st. And I've put the year in. I stripped out the date here, and I put the year in. And I left everything else the same. So that's what I get. Hopefully you get an idea here. Now I'm going to go to the next area, which is using R. I use RStudio for that. It's a pretty common package. It's the recommended package for R. You could write it in a terminal setting. It's just not as convenient. About to show you in R, I could do in Python using NumPy, and I might show that at a later date. I found it rudimentary. There's a lot of development work that you have to do that R just makes it so much easier. So let's go to R. So R, I'm just going to power it up here for a minute, and I'll bring it on to the screen. So as you can see, I got a bunch of stuff happening here, and let's start fresh, right? So what I'm going to do, first of all, R is broken down into however you want to lay it out. I have a terminal, I have a console, I have the software development area, I have the environment. You could look at history, you could look at connections. Connections are interesting because I could pull from the GitHub R library a bunch of different neat statistics, everything from heart disease to smoking to flowers and whatever. Here you have your file, plots, packages. Help is very simple, really nice to deal with. If I want to look at, say, a gplot, I can, find the topic here. Yeah, gplot. Oh wait, I stuck in the wrong one. Search up here. Gplot. So I could look up gplot and I could see what it does. Gives me a description in the R documentation, details, lots of examples on how to use it, and from everything from error bars, coloring. Now on the Geom Smooth, I use the HTML designation for color, which you'll see is yellow, and there's the viewer and the plots. If I run this right now, say I do this gplot weather out and I run it, you'll see that I get an output. The reason why I'm getting the output is because I imported the file weather out. what you do is you import the database, you retrieve the information. Now by default numbers are double. I'm going to make them integer. I'm going to take this one and make it an integer, and I'm going to make this one an integer. As you can see, the code preview shows you exactly how you're going to do it. So I could actually write this code out, open up library reader, and I could pipe weather out, read CSV Python, this here, colon types, colon column types, columns are day num, column is an integer, all this stuff, right? Pass, year, view weather out. So at the end, what's going to happen is when I import it, I'm going to see the view, and this is the view. And as you can see, I got my name number, day num, pass, year, date, min, max, temperature, and I imported it from here. Now I could plot it, and I could plot it in a number of ways. This one here I plotted as area. So what that means is gplot weather out, which is this here, and I could remove it from here. As you could see in the past, I removed it because it's already loaded into the system. And I have here weather out, AES, day num, pass. I could say x equals day num, y equals pass, but I don't have to say that because it knows that x, y coordinates. Plus the genome here is area. Now I could change the color of the area from that to whatever I want. I could go color, color equals red, and I could run it. I don't have to reload the library, but for the purpose of this I will. And there you go. Color is red, and that's my area. So I could see some interesting stuff there. I could also do a, as you said, as I showed you, I could do a view at the console, and it will know that it's weather out. Oh, I can do that. Oh. I gotta spell it right. There we go. What did I do wrong the first time? Oh, I went lowercase view. Couldn't. It's case sensitive. It had to be a capital view. So that's one of the things with their functions are case sensitive. So you have to be very careful on how you write things out and go from there. I could run view here and do the same thing. One other nice thing about the library plot, I can take the value, the file I want to read, weather out, AES, day num, pass. Again, that is the x and y coordinates. I'm going to do some jitter because there's a lot of data there, and if I don't jitter it, it'll just look like a bunch of dots. And I'll show you that later. And then I'll smooth out a function. I'm going to let, if I say geom smooth, what it'll do is it will take the best smoothing function it can find that will fit the data set. One thing I should point out also is in jitter, AES, I'm setting the color for the year. So each year is going to have a different color. Labs is a nice little function. What it does is it gives you some abilities to rename stuff. Like for example, in this gplot to when I did the area, you see it says day num and pass, and it doesn't give you much information. What I'm doing here is I am doing the following. I'm saying the title is going to be Winnipeg temperatures. The X coordinate, and I'm going to say July 1st is set to 0 day, and Y is going to be the probability. Knowing that, I am going to now, like I said, I don't have to load the library. I'll show you. I've loaded the library once, so I don't have to load it again. I could just run it, and you'll see there's a function running there, and lo and behold, it is using the best formula for the solution, and here it is. So what I have here is the year from 1940 to 2000 whatever. Actually, it would be 2018 because I pulled the data up to now, and you will see that I have the jitter gives me some idea of where everything's sitting with respect to year, and this geom smooth, which is a color yellow, is giving me this type of a curve, which indicates to me that this is the area that we're most interested in. As you can see, it fits nicely, and we can calculate based on this what the date should be for the best probability for being at minus 30 or colder. There's some functions here I could do. Mean of weather out. Well, I have to do the mean of, say, the minimum maximum temperature is minus 3.4. You put the dollar sign in. The mean of well, let's do this. Let's do the median and see where that fits. Minus 1.1. So it's minus 3.4 is the mean, but the median is minus 1.1. Interesting. What you could find interesting with that is if I look at each year, one of the fun things you could do with R is to use the function aggregate. Here, I'm aggregating the weather out file against the list of the year, and I'm going to get the mean value of it, just for the fun of it. Now I'll try it again with the median value. So what you end up getting is you end up getting it grouped. Now I ran out of space here, so they're added a little bit of another line. But anyways, the group is the year 1938, and the mean day num. You can see I only have 100, goes up to 176, so this first data set is probably not good. I wouldn't count it. But the rest are 180s, which I would count, and if you go all the way down to 81, it's 182. The year's not complete. I wouldn't count that either. But what you see is, if you see, interesting enough, we talk about climate change. 1939, the average temperature was 5.4, or the mean temperature is 5.4, and it's cooling down throughout the year. The dirty 30s maybe has something to do with it. Now we're cooling down. It's interesting because we're supposed to be heating up, but in Winnipeg, yeah, it looks like the temperatures are always getting colder throughout the years. And this one here, 81, I wouldn't count it. It's only December. The data hasn't fully been realized. I'm going to do this again, though, but this time with the median, because the median is kind of more I always find it more interesting. And again, I have some, for some reason I got some space now, so it's allowing me to do it. So the median is 181, 181.5, something like that. And the temperature, unlike the mean, is a little bit different. I have here 6, but the tendency is it goes down. And it's going down. Again, the last one, the data set isn't fully realized. It only goes, I'm missing a month or so of data, so I wouldn't count it. I won't count 181, and I won't count the first one. But as you could see, the median's a little bit more, unlike the mean. The median has a little bit more say on it. It's interesting though, the temperature is dropping in Winnipeg. Climate change, I suppose you could say. Instead of getting hotter though, Winnipeg is getting colder. I am seeing it drop, and you can see it's been steady and from, looks like it dropped to minus 2.2 in 1972, and it's staying there all the way up to 2017. It hasn't changed for a median temperature. And we could see from 1951 well, to 1957 or so, minus 0.6, staying at the 0 mark. So definitely in Winnipeg, the temperature is getting colder each year. It seems to have settled off at minus 2.2. And global warming, climate change, polar caps, whatever the case may be. You could dig a little bit deeper, try to understand what this is all about. But anyways, that's the aggregate weather. It's an interesting concept. Finally, one other thing that we want to possibly do is that we got a nice little output here of the aggregated output for the median, but we might also want to just plot it and see what it looks like. A fun way to plot it is simply by using ggplot. We're going to use the weather out, this information here, and we're going to do a stat summary. AES is going to be the year and the min-max temperature. So here we're going to get a mean value of what it's going to look like, and here we go, we're going to plot it, and there we have it. We have a mean plot with associated errors. Now, as I mentioned before, this one here, not very useful. It's way out there, less data. This one here, we don't have full data yet, so we'll get rid of these two spots, and we have a nice little line of with some error, with the error bars associated with it, so we could see that we are slowly getting colder in Winnipeg, not hotter, as the year goes by, from 1940 to 2018. That's it. I hope you enjoyed this little video, giving you a bit of idea of what it's like to run with Python for data cleansing and manipulation, as well as R. R has so many different functions and features, and it's great for a statistician. You could spend hours and hours analyzing data, looking at what's what. I recommend using RStudio. It has a wonderful help menu. It has packages that you could load, and it's as simple as clicking on the package. There's a number of packages, and as you can see which ones I've loaded, I just put a check mark, and you load it. You could do regression splines and classes, spatial, bunch of tools that are out there. Recommend getting your hands a little dirty and seeing what's out there. Well, I hope you enjoyed the video, and I look forward to doing some more in the future. Thank you, and have a wonderful day.